So inheritance or generalization. The way we worked on to implement generalization when we worked using on Java, we noticed that there were several ways that we could implement generalization in a relational database, right? And there were certain strategies that we could use, right? Remember, there was the single table, the table per class, where the denormalized and normalized. Remember, we looked at, I think there was 3 strategies that we took a look at. And I think the assignment asked you to use the denormalized strategy, okay? Now, in the relational database, none of these were supported, right? So that's why there were 3 ways of implementing it, right? Because there's no one way of implementing it because it's just not supported. And each one has its own cons and pros and whatnot. In Mongo, we have the same issue. Mongo does not support generalization or inheritance, right, per se, right? I mean, even JavaScript doesn't even support true inheritance relationships, right? So what we're going to do to implement inheritance and generalization, we're just going to use the denormalized implementation typically, right, where it is the parent base class who's going to inherit all the fields of the child derived classes, right? All those fields are going to be flattened up to the base class, right? So for instance, you might have a base class user, and then you would have faculty and student underneath that are inheriting from the user. The denormalized implementation grabs all the fields down at the derived classes, faculty and student, and then copies them over to the user. So it's kind of the reverse that you would think intuitively. Typically in object orientation, you think that it is the derived classes who inherit from the parent, right? But in the relational databases, since we don't support that, the single table implementation is to have the parent, right, the base class, to inherit all the fields from the children up to the parent. So we're going to do that same strategy here in Mongo. So what we're going to do is that we're going to create a couple of students. Apparently, I had already created a student, Ada, I guess. Let me insert a couple of users here. Here, let me see. Paste. So yeah, so I insert Tim Bernsley, who is at office 133B. And now I'm going to insert, let me see, Ada, whose username is Ada. And she is also a faculty and is right next to Tim. She's at 132A. All right, so if we do a db.user.find, we see that we have our 2 faculty, Tim and Ada. Okay. And the way we know that they're faculty is that we have a type. So this type would be for us a meta field, right? It means that at the application level, whether this is created using TypeScript or using or it's Java, presumably this field would be used to drive some logic that would cause me to instantiate either a faculty or a student, right? Very much like we did widgets way back when, and the widgets had a type, the type of the widget. And in Java, we had the different instances, right? And we then use JPA to handle that for us, right? JPA, depending on depending on which repository you were using, it would instantiate the correct data type. Yes, based on the D type meta field, right? So this type here would play the same role for us. Okay. Let's see. Let's create a couple of other folks. Let's maybe add a couple of students. Let's insert here John. And let's insert here Jane. And notice that we're using type student. apparently we are updating Jane's GPA to 3.9. And now we can either retrieve one type or the other, driven by the fact of this type field. So student retrieves me both students, and if I instead use faculty, it retrieves for me those two faculty. Make sense? Again, instead of single table, this would be single collection. A single collection for implementing inheritance. Very good? All right.